start this session. First paper belongs to Mustafa Cankurt.
Yes,
Mustafa
I'm here.
Cankurt. Are you ready to present?
Yes, I am.
Okay. You can start your presentation, please.
All right, just a second. Do you see my screen?
Yes. Please, you have 10 minutes.
10 minutes. All right, all right. And also, I'm going to present in Turkish, and I
Okay.
have 10 minutes. Just
Yes.
set it up. Merhaba, ben Mustafa Cankurt. Bahçeşehir Üniversitesi'nde biyomedikal mühendisliği öğrencisiyim. Bugün sizlere yürüme analizinde elektromiyografi sinyallerinin işlenmesinde pencere genişliğinin etkisi adlı çalışmadan söz edeceğim. Çok kısaca yürüme analizi nedir, EMG nedir, bu çalışmada neler yaptık, biraz bunlardan bahsetmek istiyorum. Yürüme analizi farklı bir takım ekipmanlarla, bu kameralı sistem olabilir, hareket sensörleri olabilir, EMG olabilir, kullanılarak bir deneyin hastanın yürümesinin incelenmesidir. Elektromiyografi ise sinirsel uyarı ile aktif olan kaslardan elde edilen elektriksel sinyallerin toplanmasını sağlar. O arada fiziksel olarak kasların kasılması esnasında çıkan elektriksel aktiviteleri incelememize olanak sağlar. Biz bu çalışmada ise tibialis anterior kasının yürüyüş esnasında oluşturduğu elektriksel sinyallerin işlenmesinde kullanılacak pencere genişliğine nasıl karar verildiği ve farklı pencere genişliklerinin yarattığı o faz kaymalarını disfleksiyon açılarının üzerinde gösterdik. Şimdi çok hızlıca yürüme dedik. Bu yürüme analizinin fazları nedir? Bir yürüme döngüsü nasıldır? Burada bir sağ topuk vuruşundan bir sonraki sağ topuk vuruşuna kadar olan kısmı görmektesiniz. Ana fazlar ve ara fazlar mevcut. Bu yürüme döngüsünün fazları ayıklanmak istendiğinde kullanabilecek farklı teknikler mevcut. EMG ile bu yapılmak istendiğinde bakın burada tibialis anterior kası aktif olduğu anları görüyorsunuz ve bir yerde bu sönümleniyor. Bu kasın aktif olmadığı bir alan mevcut ve EMG datasının incelenerek bu aktif olmayan nokta esnasında var olan yürüme döngüsünün alanı tespit edilebilir. Bu çalışmada da bizim kullandığımız sistemler her ikisi de kablosuz olmak üzere hareket sensörleri, Exens'in ve aynı şekilde kablosuz EMG'lerimiz mevcut 16 kanallı. Sensör yerleşimi burada önem arz ediyor. Çünkü siz EMG sensörlerini yerleştirdiğiniz konumdaki elektriksel aktiviteyi doğrudan tespit ediyorlar. Siz nereye yerleştirirsiniz. O yüzden koyduğunuz yerin çok doğru olması lazım ölçüm yapmak için. Biz burada Seniyem projesini kılavuz aldık. Sensörleri, kasları yerleştiriyorken açılımda Surface Electromyography for the Non-Invasive Assessment of Muscles çok güzel kılavuzları var. Burada tibialis anterior kasının yüzeyel elektromiyografi ile ölçmek istendiği zaman sensör pozisyonun nereye konması gerektiğini gösteren Seniyem'den alınmış bir fotoğrafı görüyorsunuz. Sağ tarafta da genel olarak diğer kas grupları hepsi mevcut. Burada sol tarafta bizim çekimini yapmış olduğumuz bir denek var. Bu bacaklarında gördükleriniz az önce bahsettiğim kablosuz EMG sensörleri. Fark ettiyseniz sadece tibialis anterior değil, diğer kaslara da taktık 16 sensör olmasından. Ama biz bu çalışma üzerine sadece tibialis anterior'a baktık. Üst tarafında da turuncu olarak sensörler, hareket sensörleri. Tabii biz tam vücut giydirdik. Burada sadece alt sensörlerden çıksın diye fotoğrafta yok. Sağ tarafta da EMG sensörü takılıyorken kas fiberlerine paralel bir şekilde yerleştirildiği ile ilgili ayrı başka bir kılavuz var. Bu da hareket sensörlerinin yerleşim şekli. Bu öteki kadar çok komplike veya karmaşık değil. Denekten deneye veya projeden projeye değişmiyor. Yerleri belli. O lokasyonlara kıyafet üzerinden direkt yerleştirerek hareket sensörünü de direkt başlatabiliyoruz. Şimdi denekler hem EMG hem hareket sensörleri takıldıktan sonra kaydın gerçekleştirme aşamasına geçtik. Burada laboratuvarın fiziki koşullarından dolayı 10 metrelik bir alanda denekler ileri geri git gel hareketi yaptılar, yürüdüler. Bu sırada arkada 95 dakikada 95 vuruş üreten bir metronoma çıktı. Biz deneklerden her bir vuruşlarının bu 95 BPM üreten metronoma denk gelmesini istedik. Bu da yaklaşık olarak bir yürüyüş döngüsünü bir sağ topuk vuruşundan bir dahaki sağ topuk vuruşuna kadar olan süresini 1.2 saniyeye denk getiriyor. Yürüyorken de ne çok robotik olmalarını ne de böyle fazla vücut duruşlarını bozmalarını istedik. Ama burada bir husus var. Normalde 10 metrelik bir alanda git gel yaptıkları zaman dönüş esnalarında vücut duruşları bozulduğu için vücut açıları ve farklı kaslar da devreye girdiği için tam bir yürüme döngüsünden çıkmış oldu. O yüzden normalde istenilen şey bir yüz yürüyüş kaydıdır. Bunu da nasıl yaptığımızı birazdan bahsedeceğim. Sinyal işlemeye geldiğimizde ilk olarak tabii ki bunlar bilgisayar ortamına aktarımına başlıyor kayıt bittikten sonra. Daha sonra bu yürüme döngülerin bulunmasında EMG'nin dışında o fazların saptanmasında hareket sensörlerinin büyük bir katkısı oluyor. En büyük taşlardan biri de ayağın yere olan dik topuk vuruşlarının tespiti. Şimdi bu grafikte arkada diz fleksiyon açısını görüyorsunuz. Biz hep vücudun sağ tarafıyla ilgilendik. Sağ taraftaki kas, sağ taraftaki açılar. Bu açılarla birlikte ayağın topuğun yere bastığı noktalarda kırmızıyla işaretli durumda. Fakat burada anlayacağınız üzere belli periyotlarla bir takım boşluklar mevcut. Buralar deneklerin dönüş yaptığı ve açıların bozulduğu kısımlar. Biz buraları geliştirdiğimiz ufak bir uygulamayla koordinatlarını belirleyerek direkt elimine edebildik. Bu kırmızı gördüğünüz yerler dönüşleri temsil ediyor. Maviler ise yürüyüşün direkt başlangıcı ve sonu. Bu koordinatları belirleyip inceledikten sonra herhangi bir hala aykırı veri var mı diye diz fleksiyonçuların her bir git geldi baktığımızda bütün grafiklerin üst üste eşleştiğini gördüğümüzden doğru bir şekilde bütün dönüşleri elediğimizi yorumlayabiliyoruz. Bunun aynısının EMG'de işlenmesi gerekiyor. Zaten biz demin o lokasyonları doğru bulduğumuzdan sadece frekans eşleştirmesi yaparak sistemler farklı örneklerin frekanslarına sahip. O lokasyonları direkt olarak buradan da çekebiliyoruz. Burada ham EMG datasını görmektesiniz. Bir deneyin o gitgeller yapmasının neticesinde. Az önceki lokasyonları buraya koyduğumuzda bu EMG datası sanki denek başlamış ve dümdüz bir yolda ilerlemiş gibi bir hale bürünmekte. Bunun üzerinden bütün işlemler gerçekleştirildi. Aynı şekilde bunu da kontrol ettiğimizde herhangi bir aykırılık gözükmedi. Şimdi sinyal işleme aşamasına artık daha da geldiğimizde çok uzun uzun EMG'nin sinyal işleme aşamalarına bahsetmeyeceğim. Fakat belli başlı işte alçak geçirgen, yüksek geçirgen filtremeler uygulandı. Arkadaki o gürültünün gitmesi için baseline'ın o doğrulanması ve gördüğünüz gibi şurada EMG sinyali yapı olarak hem pozitif hem negatif tarafta çok simetrik bir yapıda olduğu için birbirlerini matematiksel işlemlerde götürmesinden dolayı rektife, full length rektife yapıldı. Daha sonra burada EMG'nin fazla girinti çıkıntılı yapısını gidermek için dalga zarfı metodu kullanılıyor yumuşatmak için. Asıl olay burada başlıyor bizim çalışmamızın. Bu işlem yapılıyorken dalga zarfı metodunda kayan pencere tekniğinde o pencerenin genişliğinin değerinin çok doğru saptanmasının neden önemli olduğu ile ilgili şimdi bir takım bilgiler göstereceğim. Bakın burada şu görmüş olduğunuz kısım aynı yürüme döngüsünün, aynı deneyim yürüme döngüsünün farklı pencere genişlikleriyle yumuşatılmış hallerini görüyorsunuz. Arkada da aynı disfleksiyon açısı sahip. Bakın bu 50 milisaniyelik bir pencere boyutuyla yapıldığı vakit böyle bir girintili yapıya sahipken bu 100 milisaniyelik bir pencere genişliğine çıktığında datanın ciddi bir şekilde yumuşadığını görüyoruz. O zaman biz bu pencere genişliğini çok fazla uzatırsak çok yumuşak bir dataya sahip oluruz. Ama evet, ama bir yandan da bunun getirdiği negatif yönler var. Bunlardan biri de data yumuşuyorken aslında birazcık da datayı bozması kendileri birlikte. Burada da ondan bahsettim. Yani burada bu neye sonuç veriyor? Biz burada tibialis anterior kasının pasif olduğunu biliyoruz tekrar bu noktaya kadar ve biz bu aralığa odaklandığımız zaman kasın pasif olduğu alanda bu fazdır demek istiyoruz. Mesela şurada kas pasif oluyor ve tekrar buraya kadar gidiyor. Ama biz buna o pencere genişliğini arttırdıkça buradaki faz kaymasını şimdi çok net göreceksiniz. Bu hiç yumuşatılım yapılmamış ham EMG datası. Gördüğünüz gibi çok girintili çıkıntılı. Bunu bir takım işlemlere sokmak için yumuşatmak gerekiyor. O aşamaya başladığımızda 20 milisaniye kullandığımızda bir takım yumuşatma var. Fakat yumuşatma çok yetersiz. Burada yeşille gördüğünüzde 20 milisaniye pencere genişliği kullanıldığında başlayan pasif zaman ve bittiği pasif zaman. Arkadaki kırmızı da bütün grafiklerde orijinal noktalarını gösteriyor. Bu 100 milisaniye geldiğinde yumuşatmanın artık gittikçe daha makul bir seviyede olduğunu ve faz kaymasının da yani artık başlangıç ve bitiş noktalarının orijinalinden çok da uzakta olmadığını görüyorsunuz. Yani 100 milisaniye makul kullanabilecek bir pencere genişliği. Bakın daha da arttıralım, daha da yumuşak olsun. yani ilk başta böyle bir yola çıkılırsa artık datanın iyice fazla yumuşadığını ama 200 milisaniye kullandığınızda datanızın olduğu artık pasif zamanın başladığı noktanın orijinalinden çok daha farklı bir yerde başladığını görüyorsunuz. Bu veriler incelendiğinde datanın orijinal hali 390 iken 200 milisaniyelik bir yumuşatma kullandığınız zaman o pasif zamanın 390 milisaniyeden 190 milisaniyeye kadar azaldığını görüyoruz. Yani bu da sizin bulduğunuz yürüme döngüsündeki o aralığın yarı yarıya yanlış bulunduğunun, yarı yarıya daha kısa bulunduğunun bir sonucu. Burada da sadece aynı döngü üzerinde değil, aynı deneyin farklı yürüme döngüleri üzerinde yapılmış işlemleri görmektesiniz. Ama hepsinin ortak özelliği pencere genişliği arttıkça o aradaki pasif zamanın gittikçe kısalması. Bu sadece yürüme üzerine değil, bir EMG işlemi yapılıyorken EMG'nin aktif veya pasif olmasının bulunması gereken her konuda EMG yumuşatılıyorken kullanılacak olan bu pencere genişliğinin çok dikkat edilmesi gerektiğiyle ilgili önemli bir bulgu. Sonuç olarak kısa kullanılan pencere genişliklerinde datanın yeteri kadar yumuşatılmadığı ama fazların fazlasıyla da çok da kaymadığı, pencere genişliklerinin fazla büyük kullanıldığında datanın çok yumuşadığı, çok pürüzsüz bir dataya sahip olunduğu ama ne yazık ki başlangıç bitiş yani EMG'nin aktif ve pasif olduğu zamanların çok değişmesi, veriyi bozmasıyla karşı karşıyayız. Bizim kullandığımız veri setinde 100 milisaniyelik bir pencere genişliği kullanmak gayet makul bir sonuç verdi ve insan yürüyüşünde de genellikle 50 ve 100 milisaniyenin doğru aralıklarda olduğunu görüyoruz. Teşekkürler dinlediğiniz için. Eğer bir soru varsa alabilirim.
Thanks for your presentation. Dear participant, do you have any question about this article? Okay, no question. Thanks a lot. I wish you success.
Thank you.
Dear Mirana Todorova, are you ready to present?
Yes. Hello.
Okay, you can start if you are ready.
Just a second to turn my presentation. Thank you.
Okay, you have 10 minutes, please.
Thank you. Are you seeing the presentation?
Yes.
Okay, perfect. So I am Mirana Todorova Ekmekci from Bulgarian Academy of Science in Bulgaria, and this is my presentation. The topic is using innovative technologies, digital media, insight tools for presentation and sustainable preservation of cultural heritage. Please tell me if any of the slides is stuck or you don't see it for me to do something about it. These are the topics which are in my paper, which will be published. I have given a lot of research and examples of innovative technologies and tools used for presenting cultural heritage, including augmented reality, virtual reality, 3D printing, 3D models, serious games, smart applications, and even storytelling with robots. I will focus on this presentation of showing the examples, and more information about them can be read in the paper, or if somebody is interested, can write me. These are examples of collaborative repositories, libraries, open science, shared knowledge. Why they are important? Because this way all of us scientists are finding researches and objects easier. This is the target of European Union since 1-2 years, plus Europeana is a great example of sharing cultural heritage objects and access to museums in an open source way. It's quite complicated system and verification to be included in Europeana, but it gives a very broad access of people to cultural heritage. Of course, all the cultural heritage objects should be uploaded with meta tags, configurations, and a lot of information as a category in order to be easily found and searched in Europeana or CC Hawk and Daria EU, which are the common places to upload. Another example is the Bell project in Bulgaria. You can see on the screen, I hope, site with bells, with multimedia, text and audio of old bells in Bulgaria. This is a project of Bulgarian Academy of Science, and hundreds of bells have been recorded, categorized, and uploaded in an organized manner on this site. The site is also developed by scientists of the academy, and it's innovative for Bulgaria because most of the museums and cultural heritage in Bulgaria are not so rich or so easy to access in a web platform to access and search. This is another example of the Louvre Museum, which we are trying now to replicate in Bulgarian museums. It's a quite complicated web system with booking, with online booking, with events, access to cultural objects digitized and uploaded online, categorizing them and organizing, searching the database is actually one of the most complicated things besides the physical work in the museums, but it's necessary in nowadays to do this. There is a research, it's also stated in the paper as a statistics by European Organization of Museums. It states that only 20% of the cultural heritage in the European Union is online, and actually EU is trying to make it much more accessible with developing such web platforms and financing such web platforms for this cultural heritage to be more accessible. We are now working on with the team with the Regional Museum Bulgaria of Ethnology in Plovdiv city to make this cultural heritage in a web platform with audio access and access for disability people. Here are also some examples for 3D printing models and restorations and recreations. My paper describes more in detail the Madonna of Pietranicho restoration. You can see here pictures of it. And on the right side, there's 3D printed models by a Bulgarian museum, which were made in an exhibition. This became quite popular, printing 3D models and making exhibitions with it. Literally, at least 80% of Bulgarian museums already have this technology for 3D scanning and printing, but actually few of the staff actually knows how to use it properly and does it, but it develops now in time and more they are starting to use it. Virtual recreation, this is a nice example of virtual reality, a project which shows underwater world with old objects and archaeological discoveries. I will not enter much in detail to be in the 10 minutes time. And this is an example which probably the viewers in this conference know very well. Zelma Mosaic Museum in Turkey. I have been personally there with Mavlevi Museum in Gaziantep, and those are very nice examples of using digital technologies together with physical space to represent cultural heritage, including smart games, serious games with puzzles, arranging mosaics, digital screen on the spot with touch screen and responding to people. Many examples in this nice museum. Another example is those digital displays on the screen. Many of them have these serious games, interactive screens, which are leading you through history and knowledge. And to be more concrete with one example, which was most impressive for me in my research, and which includes most of the digital technologies which I'm talking about. If somebody's interested, I really recommend to see this example. It's called Mosti. There is in YouTube detailed information about it by the creators. interactive digital museum, science and technology museum in Saudi Arabia. It has a 3-meter long digital table with every kind of digital technology included, including touchscreen, multiple screen touching of many people, multi-language, serious games, virtual reality even in the museum, and responding to distance and to close touch, and combining interactive objects on the spot with a very complicated digital system. And another project which I really recommend those who are interested in the topic to review is the big data collaborative project, The Time Machine, which combines thousands of documents, photos, videos, and information from the past and the current history of many countries. Everybody can, not everybody, but institutions dealing with cultural heritage can apply and collaborate in this project. The aim is to combine all this huge amount of data and through artificial intelligence to categorize, gather and present this information in a more accessible way for people online, instead of them circling, let's say, 3 or 4 different museums and institutions to understand what has been in the 80s or in the 90s. This project aims to present all in one place, all the objects and knowledge of different institutions together. It even makes 3D models of objects and places which do not exist anymore, historical ones, and even it prognosticates how they will be looking in future and compares past, current, and future for cultural heritage. This is also a way to preserve it. These are some examples for augmented reality and virtual reality. It's called Story of the Forest in Singapore. It's again amazing digital project with touch screens, multi-screens, smart technologies, and serious games. You can see more if you wanna get more information about it. And something which has been popular in the last 2 years in Europe, digitalizing old, very important historical paintings, virtual reality making on them. This is one example in Helsinki, Finland, of their National Museum, made in 2018. There is also around this time made similar one of Mona Lisa, explaining the painting and entry into the painting as a created virtual reality for the viewer to really experience this period and the history which this painting represents. This, of course, includes very complicated technology, but I don't have time to enter in detail about it. And these are 2 examples from Bulgaria of holographic images and augmented reality and virtual reality images. One of them is Bishop's Basilica Philippopolis at Plovdiv city, Bulgaria. I really recommend if somebody has opportunity to visit. It's again very modern museum with digital screens, with people appearing in a digital virtual way on the old super historical mosaics, a very interactive way made for people and very technological, combining old history with digital technology to present it in a better way, to present us the things which have already disappeared and we cannot see, made by 3D models and other technologies. And this is one very important example about accessing cultural heritage of people with disabilities. It's called the Touching the Masterpieces, and it's made by a gallery in Prague. Complicated technology with a touchscreen system, which enables blind people to experience very important historical objects. In this case, Nefertiti's Nefertiti mask statue, Michelangelo's David. It was very popular, and actually it was used, this application and this technology, not just by blind people. Normal people also wanted to experience the artifacts which otherwise they cannot touch in museums. And the last example, which I will give, probably again, many of the audience people know it, the Masao Shitosu. I have been again personally there. It's a great example of telling stories with cultural heritage stories and fairy tales in a very modern way, with robots, with a complicated visual and system responding to people getting close, and robots are starting to talk and explaining stories. In my paper also there is another example, Ivana Museum from Croatia, and it's very, very interesting how cultural heritage is not only presented anymore by pictures or text, but by complicated web platforms, robot systems, interactive systems, and everything is combining cultural heritage on the spot with digital experience, which enriches the experience of the people and makes it more important for them and more easy to perceive. Thank you for your attention, and this was my presentation.
Thanks for your presentation. Dear participant, do you have any question about this article? Okay, no question. I wish you success.
Thank you.
Ms. Mirena. Next paper belong to Mr. Theodore Kalushko.
Yes, I'm here.
You have to pay. If you are ready, you can start your presentation.
Okay.
You have 10 minutes per page, per paper.
Okay. So I'm Theodor Kalushkov, and now I will present you a report about an approach to development of virtual reality training systems. Oh, I'm sorry, it's the other presentation. So this is the right one. I and my co-authors from St. Cyril and St. Methodius University of Veliko Tarnovo are very happy to continue this year our participation in the conference. The present study addresses issues related to the implementation of virtual reality in the practical teaching of students in the most general sense and training staff for industrial enterprises. The focus of both cases is to improve the practical training of learners. Future practitioners must not only know, but also be able to. Therefore, practical exercises are introduced in almost every training. Their practical skills must also be tested to ensure that they are well prepared in the specific field. There are some areas where the acquisition and verification of practical skills is very difficult or impossible. Here you can see some examples. There are three types of VR according to the degree to which the user is isolated from the physical surroundings while interacting with the virtual environment. The non-immersive system display in the virtual world without additional devices, such as head-mounted displays. This type of VR systems are called desktop VR. Semi-immersive systems still use a conventional monitor, but they support partial body tracking through the use of spatial gloves or spatial glasses. The augmented reality is an example of such system. Fully immersive systems are the ultimate version of VR systems and allows users to obtain virtual environments as in the real world. The virtual world is a space generated by a computer in which one or more users interact with one another via graphical representations called avatars. Immersion creates the perception of the world that the user lives inside it and can touch it. Sensory feedback represents the user's ability to observe the results of their activities. Interactivity gives the user the ability to modify and interact with the objects in the virtual world. This is achieved through the use of sensors, which provide the users different styles of interaction. This table shows the comparative analysis of VR systems. It aims to help users to find out which category of VR systems would be most suitable for their purposes. The table summarizes the information about the possibilities, what possibilities provide each subcategory. In addition, use of education column has been created to present the use of different VR systems for training purposes. After analyzing the problems and opportunities for developing virtual reality training systems and systematizing the lessons learned from the experience of the authors gained in the implementation of such applications, the following critical requirements for this process were highlighted. Development of virtual reality training system usually requires large effort, long period of time, human labor, and high cost. In order to justify such an endeavor, it is very important to determine in advance the expected results and benefits that will be achieved from such innovative training. Defining the specific tasks is one of the important steps in planning the developments of VRTS. An optimal solution must be found for each of the tasks, and they largely determine the achievement of the ultimate goal. The to-do list also shows developers the complexity of the upcoming development process. The main tasks can be summarized as follows. The division of the implementation process into several stages is a very positive practice. We offer 4 stages in the development of VRTS. First stage is research. Should be performed a study of the target object, the operational documentation of the equipment, and the educational methodical documentation should be procured and analyzed. Stage 2 will be documenting. The documentation should be prepared by systematizing all the obtained initial data. Stage 3 is development. The training system in a VR environment should be developed. The software should be tested and the training scenarios should be verified. Stage 4 is operation. This stage includes the operation of the system in the real conditions and its improvement. The choice of virtual reality technology depends on the defined requirements for the training system. The type of VR must be set in the project assignment. Then in the research stage, the exact model is chosen and assembled and assessed in the implementation. Here, the software development kit needs to be considered for that device and whether it is compatible with the VR application development environment. In some cases, a specific type of VR equipment may be predetermined, but this cannot change the model of the VRTS development process proposed. The model we offer contains 6 modules. Each of them provides certain functionality. These are login and form and VTRS manager, which provides identification of administrators, trainers, and learners. Database stores the data of all learners. Scenario creator allows trainers to create training and testing scenarios on predefined elements of the existing VR places. VR menu room provides students with the opportunity to choose the scenario that they will be trained in. VR scenario elements are VR spaces in which learners are trained or tested in a predetermined sequence of actions. VR places elements are VR spaces in which participants are trained in a VR environment. This architecture of logic is exemplary and follows the model presented in the previous slide. The main objects here are 3D interactive models are the models attached with the mechanics so that the user can interact with them via VR controllers. VR controller model consists of all methods that control the signals from the VR controllers. VR Interactions Manager represents all methods that control the mechanics and 3D interactive models. Training Manager monitors the correct course of the training and generates the relevant data for the session of the current user. Database is an external object for the session. The results and effects of the training carried out on a VRTS must be analyzed according to the specified criteria, and it is possible to prepare a scale for evaluation each criteria. This will make it possible to obtain a final assessment of the system in terms of its overall effectiveness. With this, I want to thank you for this presentation, for your attention, and to say that if you have any questions, we are
Thank you for your presentation. Dear Pasim, do you have any question about this article? Okay. Mr. Theodore Kalushko, you can start your second presentation.
Okay. The other report that I will introduce you now is called Sensor Network with Accelerometers for Reliable Pothole Detection. The suggested system uses detection node with 2 accelerometers. Its main goal is to make analysis of the potholes on the road surface and to visualize on the map the bigger ones, thereby increasing the safety and comfort of all passengers. The system exploits 2 detection methods based on Z-axis algorithms to determine the number and location of potholes using a mobile phone and an external controller with a GY521 sensor. The development of electronic components in the last years allows the integration of multi-axis gyroscopes and accelerometers into mini chips housings with wide range of applications. Most smartphones, some vehicles, some security devices, drones, toys, and game controllers use such a chip. It recognizes the position of the device in the space and allows to react adequately to changes in this position. One of first application of such chips was for early warning of elderly people falling to the ground. Typical fall detection systems determine whether there has been a fall by analyzing patterns of human movement, such as changes in speed or changes in body position. A drop detection algorithm based on the predefined threshold values from acceleration sensors was developed from some scientists, and its mathematical expression can be observed from this slide. Microaccelerometers have many other applications, and one of them includes pothole detection. Our report mentions such studies, but here are listed several main disadvantages on the state-of-art systems. One of the widely used algorithms in these devices identifies changes in the amplitude of z-axis acceleration that exceeds a predefined upper threshold value. That's why it is called z-thresh detection algorithm. And the second most used pothole detection algorithm is the advanced z-diff algorithm. It makes two consecutive measurements of the vertical acceleration along the z-axis within a certain time slot and analyzes the difference between their values. If this difference exceeds a predefined threshold value, a pothole report is generated. Some authors have developed z-diff algorithm by calculating an average level of sensor measurements, called also baseline. In this case, the current difference from the baseline can be calculated by this formula on the slide. The architecture of our system is depicted on this slide. To achieve high reliability, a combination of two algorithms, z-thresh and z-diff, are used. The external controller uses z-thresh algorithm, while the smartphone uses z-diff. The mobile phone serves also as a gateway to the internet and tracker. Double pothole detection with both devices in a single detection node is the first innovation that aims to increase the reliability of the whole system. The next step in our work was to choose the sensors and the other equipment for our prototype and testing. On this slide, you may observe the basic parameters that we took into account. Node MCU or ESP8266 was selected as a wireless controller. It uses a Wi-Fi connection and has ready libraries to work with GY521 sensor. Another possible option is ESP32. It can operate by Wi-Fi and also by Bluetooth connection. On the left picture, you may see our hardware prototype, and on the right, there is a screenshot of developed on READ application interface. It shows the GPS coordinates, acceleration of the three-axis, and has controls for sensitivity setup. A button for test sending a report is also provided. The rest part of our experimental environment is listed on this slide. It describes the car, the smartphones that we used, the database, and we also use Google Maps map. The proposed system has been tested in our city, Veliko Trnovo, Bulgaria, where a random road with a length of 5 kilometers was chosen for the test. After multiple passing the road, the system displays on the road map only the large and medium medium-sized potholes, the location of which is registered 4 or more times in the database. With the applied threshold value of 0.3G for the ZDIF algorithm used in the mobile phone, together with a threshold value of 0.3G for the Z-thresh algorithm used in the NodeMCU, 30 large and medium-sized potholes along the road were reported, 26 of which were true positive. For the Z-thresh algorithm running on NodeMCU with the connected acceleration sensor GY 521, a threshold raw value of 7,000 units was selected, which corresponds to 0.43G. Subsequent downward corrections resulted in an optimal result at the threshold of 0.3G. When threshold of 0.8G for both algorithms, twice fewer potholes were located, taking into account only the larger 9 potholes. The figure on this slide shows 8 already discovered potholes through positive results from multiple tests along the same road using the threshold values of 0.8G. Here, the rates of true positive and false positive results can be observed by both algorithms on threshold values of 0.3G. As a conclusion, we may say that the results of real experiments show that by combining Z-thresh and ZDIF algorithms with different thresholds, the pothole detection system improves its accuracy when detects large and medium-sized potholes, and this approach is an effective solution for locating them on the road. So I want to thank you. If you have any questions, we are ready to answer.
Thank you for your presentation. Dear participants, do you have a question about the article? Okay, no question. Thank you again. I wish you success in your career,
Thank you.
Mr. Theodor Kalishkov. Next paper belong to Nashim Ahmedzadeh. Are you ready? Okay. Nuch Hapol Kisasan, are you ready to present?
Yes.
Okay. If you are ready, you can start your presentation.
Okay. Let me share screen.
Please, you have 10 minutes.
Okay. Okay. Can you see my screen?
Yes.
Okay. Good morning, everyone. I am Nachapon Kistan from Mahidol University, Thailand, and my research is AR Sci, the framework for building augmented reality in scientific learning. So, what is the problem? And nowadays, science is an essential part of education, regarded as fundamental knowledge of other subjects. The effectiveness of science and education depend on the appropriate techniques and material used in the lesson to improve student attitude and efficiency of science education. So, the common problem in learning science education are the lack of equipment, teaching style that is not standardized. Students generally lack motivation and have low self-confidence in learning, and the intensive curriculum but insufficient time allocation for science education. And how AI help in education? The integration of AI technology in education can improve the learning environment to include a variety of learning resources that allow students to acquire learning content easily. And it was found that AI technology has been applied in many fields of education, such as medicine, biology, physics, and humanities. The integration of AI in science education has shown many benefits to scientific learning, and the factor influencing scientific learning, such as the sound, image, and animation, can be represented in many ways, facilitating students to interact with invisible scientific phenomena that are like in real life. And why we should use this framework? Therefore, the problem about design application is does not have suitable framework to create an AI application in science education, and this leads us into integrate the finding of a literature review conduct to identify the potential use of AI in science education and examine the state of art in AI for scientific learning. From the research, we have shown a framework for using AI in learning science and analysis of research on AI in science education. By integrating the research finding and analyzing the research can provide a theoretical basis for practical guidance to current and future education with AI in science education. And what about AI for science education? Before I'm talking about the AI science framework, I will talk a little bit about AI technology in science education. And science education is a field in that AI is particularly essential because students often have difficulty in learning science from the abstract concept content. AI technology use virtual object and real environment that easy for students to understand complex abstract concept of scientific learning by enabling three-dimensional model representation in difficult to visualize event or objects, and the ability to show three-dimensional model is important in an science field. For example, in anatomy field, the teaching method will rely on physical model of physical characteristics to show the structure of the human body. AI is used to improve students' understand of the spatial alignment of cell or organ without physical model or physical characteristics. And researchers have listed the use of AI application within a variety of educational fields. This study focused on 19 pieces of research on AI in science and education that's published between 2017 and 2021, as shown in the slide. There are various scientific fields in which AI is adapted for science learning, consists of science, biology, chemistry, and physics. Most of the research studies show the participant positive feedback regarding AI as a tool for interacting with the topic. With the aid of AI technology, the learning of science that involve visualization will be improved compared to the use of traditional methods. And before I'm talking about structure of AI science framework, we will talk about learning theory that used in the review research. From the review paper, we found 40% of all research that use the learning theory from AI application. And separate to the, we found 20% research that use a TPAC for science education and 10% that use VROOM taxonomy for science education. And the other learning theory is a 10%, and no learning theory is more than 60%. So we try to create the framework to support the design of AI application that use the foundation knowledge from review research. And for the first theory that we found most in the review paper is a TPAC. Is TPAC offer a productive solution to many problems that teachers commonly face in education with technology in the classroom. TPAC designed the order to enhance student learning experience by communicating and support the pedagogy. The content and pedagogy must create the foundation for effective education. Technology integration in the classroom. It uses technological tools such as hardware, application, or website to teach students more about the subject. It has three types of knowledge in TPAC framework, consist of technological knowledge, TK, pedagogical knowledge, PK, and content knowledge, CK. The three types of knowledge are combined to the new expertise within the TPAC framework, which generate three more types following the slide. And technological pedagogical knowledge, TPK, it describes relationship between technological tool and pedagogical practice. And the next thing is a pedagogical content knowledge, or PCK. That it describes the relationship between pedagogical practice and learning objective. And the next thing is a technological content knowledge, or TCK, that describes relationship among technology and learning objective, and all of things combined to the TPAC. And the next is another learning theory is a VROOM taxonomy. And the VROOM taxonomy can help educators understand how students acquire an understanding of the lesson. VROOM taxonomy is separated into 3 domains, consists of cognitive, affective, and psychomotor. And educators have focused on the cognitive model in education. It consists of the knowledge is associated with remembering information, and comprehension is a capability to expand the meaning of the information. And application is a use of the information in new situation. And analysis is combined breaking down into a part to expand how the two process work together, or identify why system is not working. And synthesis is a connecting part together to create or integrate a new part. And the last thing is that evaluation is assessing theory to compare the idea. And what is the AR-SI framework? The AR-SI framework is a hybrid framework between the TPAC and the VROOM taxonomy. That it has 3 layers, consists of theory layer, AR layer, and the outcome layer. And this is a structure of the AR-SI framework with the learning theory. And for the first thing, I will talk about the theory layer. The theory layer provides a lesson about AR that useful for science education, and find suitable learning theory. Is it a foundation for create the learning material in the AR layer to organize learning objective and goal for scientific learning. And TPAC is the framework that is suitable for this framework. And learning goal has 2 steps, consists of identifying a goal and analyze a student. Identify a goal step is identify the goal of learning that can be affected by the integration of AR, such as the knowledge or learning content. And the aim to explore the knowledge students should learn attitude for science education, and learning content represent in AR technology. Analyze student step is to improve learning outcome with AR technology and student difficulty in learning content. And beside the learning objective has 2 steps. There are planned learning material and choice of suitable resource. Planned learning material step is the appropriate learning material for support student. Choose suitable resource step is to find the good material associated with AR technology and the user of technology to represent the learning content by the teacher. And the next things are the AR layer is designed to learning material from combined between theory layer and learning environment to provide learning material for support the outcome layer with AR environment. The choice of learning material should be selected in the theory layer, and the characteristic of AR the learning environment has 4 types. For environment consists of feeling, watching, thinking, and doing. Learning material has access to the educational content and can use their handheld to connect the AI and interact with educational content. And the last component of this framework is the outcome layer that aims to support the achievement of learning material to find learning outcome, and it helps to understand the student ability and attitude towards science from learning material with AR. The outcome layer combines criteria with learning material and VROOM taxonomy framework. VROOM taxonomy has been used to estimate student learning outcome ordered by the degree of difficulty. It could significantly improve student cognitive capability and effectively scaffold knowledge about target plan in the observational learning activity. And to demonstrate how the AR-SI framework can be integrated on site, we will show the example of the research to access the framework. If the researcher use this framework to design application, and the application that we will show is use AR technology to learn biology content consists of photosynthesis. From the first step is to identify student goal and attitude for scientific learning, then find the connection between AR technology and learning content. Educator find the goal of the learning from learning content, such as my student will understand and be able to expand in own words. in structure and process of photosynthesis with 70% accuracy. And the use of AR is to visualize the process of photosynthesis in AR application. And the second step is to analyze student by analyze AR with the learning outcome and difficulty in learning content. Educators should prepare a brief class to teach the foundation knowledge of learning content to student. Teacher teach about inorganic compound to improve student understanding of the foundation compound of the photosynthesis process. And the third step is to plan learning material by finding the appropriate learning material to support students. For example, the teacher find the benefit of mobile phone and personal computer in the photosynthesis learning content. And the fourth step is to choose a suitable resource and use the technology to represent the learning content. Teacher choose mobile phone that is the best tool for support learning with photosynthesis because it is simple and easy to use for primary school students. And teachers should participate in mock-up class to learn the use of AR in the learning content. And the fifth step is to select an environment from the learning activity, such as teachers choose the watching learning environment because the photosynthesis should learn by watching the process. And in the last step, to define the outcome of this learning material by following Bloom taxonomy framework, students receive the knowledge level of Bloom taxonomy from photosynthesis learning application, and it uses the outcome layer to analyze the summary of the framework in the data analysis process. And that's all of my project. Thank you.
Thank you for your presentation. Dear participant, do you have any question about this article? Okay, no question. Thank you again. I wish you success.
Thank you.
Mr. Nazım Ahmet Zadeh, are you ready? Okay. Mr. Oğuzcan Uludağ, are you ready?
Yes, I am ready.
Mr. Oğuzhan could not present his presentation because he was not available yesterday. Okay, you can start your presentation if you are ready.
Thank you. Let me share my screen. Can you see my screen?
Yes.
Okay. First of all, let me introduce myself. I'm Oğuzcan from Ege University. My department is computer science in the Department of Mathematics. In this study, we worked on financial risk estimation with KNN classification algorithm on determined financial ratios. What is financial risk? To sum up, we can say that financial risk is the possibility of losing money on investment or business venture. And also financial risk may develop some financial distress. What is financial distress? Financial distress is the inability of a firm to meet its debts. And it leads to the company being close to bankruptcy, going into liquidation, and even confiscating the company. For this reason, it's important. Estimating financial distress is crucial to the success of businesses. Especially early detection of financial distress can minimize the effects of financial distress on the business. Additionally, they can reduce the company's risk of depreciation for investors and lenders. In this study, classification KNN algorithm, a data mining technique also, are applied to determine financial ratios. And the Springate model was used to determine the financial status of the companies. And then the results have been analyzed. How did we prepare the data set? Firstly, the balance sheet tables taken from Kamu I do not know platform, it's Turkish, of different companies operating in the manufacturing industry sector between 2013 and 2018 have been used as data set. And total of consists of 1,027 records. Then the Springate score of each record has been calculated. to set financial status of companies, and determined financial ratios of each record also has been calculated. Then these data has been merged. What is Springate model? Springate developed the model uses the multivariate discriminative analysis, and there are 4 basic ratios in this formula, as you can see below. According to S value, it's interpreted that the firms are successful or unsuccessful. You can see there are 4 ratios, x1, x2, x3, x4, and according to calculated S value, if S value is less than 1.862, it's predicted that the company will go bankrupt. And financial ratios used, a total of 10 ratios that affect the financial status of companies have been used. With these rates, you can access the following information. This is important: the efficiency of the business in its activities, the share of the net working capital, the liquidity of companies, the current financial strength of the company, borrowing capacity of the company, the stock activities, and allows to make judgments about the company's investment and financial policies. And also, I want to explain what is KNN classification algorithm. The purpose of classification is to determine which class the data belong to by looking at the similarities. And it classifies the new element to be classified by looking at its proximity to its K neighbors. And as you can see, the figure 1 shows the steps of the KNN algorithm. In step 0, there are the green painted points of class A, the points of class B painted in orange, the points of class C painted in green, and the unclassified gray point. In step 1, the distance of the gray point to all other points is calculated. In step 2, the K nearest neighbors to the gray point are listed. For K equals 4, the class with the most members in step 3 is A, which is green. Then the gray point is labeled class A. How we implement? KNN classification algorithm has been used in the financial situation analysis of companies operating manufacturing industry, and using the balance sheet of 179 companies, the financial ratios of each company used in the study have been calculated, and the Springate score of each firm whose financial ratios have been calculated and their financial status has been labeled. Cross-validation has been applied to group the dataset. The reason for using cross-validation is to reach the most objective and accurate results possible by evaluating the results obtained for different part joinings. The dataset has been divided to 10 groups, and KNN algorithm has been run for each group. And there are a total of 459 companies, as you can see left side, whose financial situation is fail. 404 of these records have been classified correctly, and 55 of them have been incorrectly classified. And result accuracy rate of 88.02%. For 568 companies with good financial status, 504 records have been classified correctly and 64 records incorrectly, an accuracy rate of 88.73%. And according to general table, 88.42% accuracy has been obtained. Our references. Thanks for listening.
Thank you for your presentation. Dear participant, do you have any question about the paper? Okay, no question. This paper was the last paper of this session. So I want to end the session. Dear participants, hope to see you at next session. Have a good day.
Thank you.